Dear students, I am Dr. A. Assistant Professor, PG Department of Computer Applications, St.Joseph College of Arts and Science, Autonomous, Cuddalore 1. In this session, we will discuss about fixed partition memory management in OS. Fixed partition memory management. Here, the memory can be divided into different sections. Each partitions are fixed. The size of the partition may be equal or unequal. Here, the information regarding about the partitions are stored or maintained by the partition description tables. Here, in this session, the partition description table store information about the memory which are allocated and the memory space which are not allocated. The partition description table give information about the partition ID, partition starting address, size of the partition and status of the partition. Here the status represent whether the specific memory space is allocated or free. In this picture represented the size of the spaces occupied by the OS are 100K. The starting address of the partition 0 is 0. It should be, and everything should be managed by the process description tables. Here, partition 1. The partition 1 is starting address is 100K. The size of the partition is represented as 2K and it is not allocated. The status is represented as free. And then partition 2. Partition 2, here the starting address is 300K, the size of the partition is 100K and it is allocated. And then partition 3. Partition 3 is allocated by the process B. Here the starting address of the partition is 400K, the size of the partition is 300K and it is allocated by the process B. Then the next partition P4. Here it is not allocated, it is a free one and the partition 5 is allocated by the process C. Here the main memory is divided into the 6 partitions, that is P0 to P5. Each partitions are different size and the partition is different size. Here the partition description table discuss or describe and it will store information about the particular process. Here the allocation, the mechanism of the allocations can be followed in the fixed partition main memory is first fit, best fit, worst fit. First fit, the size of the file is closest or nearest to the size of the partition is called as the best fit. The size of the file is allocated to the first nearest size of the partition is first fit. The size of the partition is allocated to the largest memory space of the partition is known as worst fit. According to the fixed partition, the process D will be stored in the partition P1. Here it will be based on for example, consider, already I explained, first fit means based on the size of the partition which is closest to the nearest size of the file. In our example, if you want to store any file means based on the first fit, suppose consider the file size is 80K means where it will get stored, it will be always stored on the first one. Which one it is called is process P1. In the P1 partition it will be get stored. Worst fit means it will be chosen the largest memory space which is free. So the largest space which one is free is called as 300K, that is 700 to 800K or 100 to 300K. Here the largest memory space which is not allocated is P1. Here only it will be get stored. Okay. This one is the worst fit. Worst fit means the size of the file, it will be stored on the largest partition. So here the memory space largest partition means P1 is the largest partition. So based on the worst fit, the file which will be allocated on the P1. First fit means here it will consider which memory space will be applicable to the size of the file. Based on that, it will be allocated. For example, worst fit means, so for example, the size of the file is 800 means the partition size will be nearest. So the nearest partition size is P4. So the file will be will be allocated. So the best fit is the best one. And the next one is the multiple queue and the single queue. In the multiple queue means there will be many queue. Here the multiple queue will be followed in order to avoid internal fragmentation. Here the partition, already I told, the fixed partition will be partitioned on the different sizes. Each partition will be different sizes. Based on the size of the partition, the sizes of the process which are going to be allocated will be to be formed on a queue. For example, the size of the partition is 2K means the size of the file which is the process which is less than 2K will form a separate queue. The 8K means the process which is greater than 5K and less or equal to 8K will be form a separate queue. The process which is greater than 2K, less than or equal to 5K will form a separate queue. Here in multiple queue, the advantage is here memory wastage is avoided. Internal fragmentation will be avoided. Disadvantages means, suppose the largest, the smallest, smaller partition, the longer queue, there will be a longer queue for a smaller partitions. Here, even though the bigger partitions will be empty or remain unused, the longer queue for a smaller partition will be waiting for a long time, and it will never use the bigger partitions and it will be remain unused. According to the single queue method, in the single queue method, here there will be only one queue, and each have a process of different types. But there will be great disadvantage will be here. Disadvantages means external fragmentations occur in a single queue method, but easy implementation and lower OS overhead. Next one is relocation address translation. Relocation address translation can be carried out by two methods: static relocation and dynamic relocation address translation. In static relocation address translation, in this method, the relocating linker or loader changes the logical address to the physical address. That is the starting address of it, can load the program into the starting address of the partitions. But in dynamic relocation and address translation, here consider the compiled program can be stored on the starting address of the partition by relocating linker or relocating loader in the static relocating address translation. In dynamic relocating address translation, this method here consider the virtual address. Virtual address means the CPU generated address is called as a logical address or virtual address. The physical memory address is that free space is allocated as in free base registers. So the virtual address is added with the base register, and it will be carried out or implemented by the memory management unit, and it creates a memory address registers. So the address will be 1500. In the space 1500, the process will be gets loaded. Then here the protection. Here protection means there will be protection key and a limit register. Protection key means here 000, 001, 0010, 0, then 011. If there is 001 means it will be for example partition 3 whose protection bit is 011, which does not match with the partition 2, which means there is protection error when access is denied. Then next one is limit register. Limit register means first here the limit register store the maximum values of the maximum limit registers. Here CPU generated a logical address or virtual address. Here the logical address or virtual address is greater than the limit register values. Here the logical address is always lesser or equal to limit register value. Here the limit register is loaded with the last logical address or virtual address. Here it's compare either the virtual address should be always less than or equal to limit register. If it is S means it should be added with the base registers, and the memory address register is created and it will be stored on the main memory. Suppose it will be beyond the limit register means protection violation error will be gets occurred. Then sharing. Here in fixed partition memory management, sharing is impossible. And then evaluation means evaluation can be categorized into three types. One is wastage of space, second one is access, third one is time complexity. Here evaluation wastage of memory can be occurred because of internal and external fragmentation. Internal fragmentation means in a small portion or a partition of a memory is wasted inside a partition means it should be called as internal fragmentation. If a free space at different location to accomplish, there should be a free space are available at different partition, then it should be called as an external fragmentation. Here the access time is very fast and the time complexity is low. So the fixed partition, here the memory, how first you should carry out how the fixed partition work. Then you have to find out the relocation and address translation. Relocation means static relocation and address translation, dynamic relocation and address translation. Static means during the compile time itself, the starting address of the program where the logical address can be going to mapped on the physical address. But in the dynamic relocation, it should be the logical address will be added to the base register. It will be carried out by the memory management unit hardware devices to find out the memory address registers. Then it should be mapped on the physical memory. After that, you should care about the protection and sharing. Protection means it should be based on the protection bit and limit register. Sharing means sharing cannot be done efficiently. The last one is evaluation. Evaluation means first wastage of memory, second one is access time, third one is time complexity. Wastage of memory means both internal fragmentation, external fragmentation happen. Access time is very fast and then time complexity is very low. I hope you may understand. Thank you. Understood until understand.